This section is logarithmic and exponential equations. So the objective is that we're going to solve logarithmic and exponential equations. So when we're solving logarithmic equations, one way that you need to do it is you have the same log on both sides of the equal sign. So you need to condense it into one log on both sides of the equal sign and then set what's inside the log equal to each other. So here to condense this one, first thing I need to do is move the 2 to condense it, make it a power. So now that gives me that. Now I have the exact same log on both sides. It's condensed as far as can be. So I set what's inside equal to each other. Now I solve for x. Well, if you take the square root of both sides, remember when you take the square root, you get the plus and minus. So the square root of 4 is plus and minus 2. But we got to make sure that our answer is in the domain of the logarithm. To do that, you plug it back in. And remember that when we talked about the graphs of logarithm, the domain goes from 0 to infinity. Has that vertical asymptote right at the y-axis to infinity. So I need to make sure that what I plug into the log is always going to be positive. It cannot even be 0. It has to be positive. So I plug in 2. Well, 2 is positive. So when I plug it into the original equation, so I'm plugging it into the original equation here. When I plug that in, I get a positive 2. So therefore, that's a good solution. But when I plug in negative 2 into the original equation, that I have a log inside the log is negative. So that does not work. So therefore, this is not a solution. So my only solution is x equals 2. I want you to try this one on your own. I'll give you a minute and then we'll go over it and see how you did. Okay, let's work this one. I need to condense, so I need to make the power, the 2 on the outside be a power, the 3 on the outside be a power. So that gives me log base 5 of x squared equals log base 5 of 4 cubed. So now I have the same log base. They're all both logs have are condensed as far as they could be. Now I set what's inside equal to each other. So that gives me x squared equals 4 cubed. Well, 4 cubed is 64. So x squared equals 64. The square root of 64 is 8. So x equals 8. But remember, it also equals negative 8. So x squared equals plus or minus 8, and I got to check both of those to make sure they are real solutions. So I plug in a positive 8 and log of into the original equation. So I plug in positive 8 into the original equation, and it works. So therefore, that is a solution. I plug in negative 8 into the original equation, and it does not work. That gives me a log inside the log is negative, so therefore that is not a solution. So the only solution I have is x equals 8. So let's do this one. Well, this one's a little different. I don't have a log on the other side. Well, let's go ahead and condense, and then we can change it into an exponential. So that's another way that you can solve these log problems. If there's not a log on both sides of the equal sign, then let's change it into an exponential. So let's go ahead and condense. So when I condense, when I add, I multiply. So now it's condensed. So I have log base 2 of x plus 2 and 1 minus x equals 1. So now I'm going to change it into an exponential. So we have, remember that logs equal exponents. So therefore 2 is the base, 1 is the exponent. So 2 to the first power is just 2. So that gives me 2 equals x plus 2 and 1 minus x. Now I just got to do FOIL. So when I do FOIL, When I do FOIL, I'll get x times 1 is x times negative x is negative x squared. 2 times 1 is 2, and 2 times negative x is negative 2x. When I combine like terms, I get negative x squared minus x, because combining like terms, plus 2. Now notice something. There's a 2 on both sides of the equal sign. So if there is, I can cancel them out. Also, I have negative x squared minus x. Well, I can factor out a negative 1. And that gives me negative 1 times x squared plus x. And then I can actually, since I have 0 on the other side, if I divide through by negative 1, I will get x squared plus x. So now I can factor that because it's equal to 0. So let's go ahead and factor. I can factor out an x. Now that I have a factor, I set each factor equal to 0. So x equals 0 and x plus 1 equals 0. I solve for x in both of them. Well, that's just the second one. So I subtract 1 from both sides. So I get x equals 0 and x equals negative 1. Once again, I need to check to make sure that both those solutions are real solutions, not extraneous solutions. So I plug in 0. I plug in 0 for x here, and 0 plus 2, it works. I plug in 0 for here, 1 minus 0 is 1, it works. So 0 is a solution. I plug in negative 1. Negative 1 here, negative 1 plus 2 is a positive 1. It works. 1 minus a negative 1, well, minus negatives plus positive is 2, so that is positive. It works also. So both of these solutions work, and that's okay. You can get that. And that's also why you need to check both solutions. You can't automatically assume that, hey, x is negative, it doesn't work. Well, it did work in this situation. So you just need to plug them in and check. So both solutions are on the domain, so they both are work. So now I want you to try this problem. Now there's a little trick. You just need to get the 1 by itself, and then it works just like the previous problem. I'll pause and let you solve this. Try it on your own. Okay, now let's work this one. So I need to move that 1 minus, or I'm sorry, I need to move the negative log to the 5th x minus 1 over to the other side of the equation. So I'm going to add the log base 5, the x minus 1, to both sides. So this is what I get. I get log base 5 of x plus 3 plus log base 5 of x minus 1 equals 1. So I just added the log 5 of x minus 1 to both sides, and that's what I get. Now it's just like the previous problem. Now I have a plus sign between them, so that means I can multiply. So that gives me log base 5 of x plus 3, x minus 1 equals 1. So now that I have a log, I don't have a log on the other side, so I can change it into an exponential. So 5 is my base, 1 is my exponent, 5 to the first power is just 5. And then that equals x plus 3 times x minus 1. Now let's go ahead and do the FOIL. X times x is x squared. X times negative 1 is negative 1x. 3 times x is 3x. And 3 times negative 1 is negative 3. When I combine like terms, I get x squared plus 2x minus 3. Now I need to move the 5 over, so I'm going to subtract 5 from both sides. And that gives me 0 equals x squared plus 2x minus 8. Now I need a factor. So to factor, what two numbers multiply to give me negative 8 and add to give me a positive 2? Well, a positive 4 and negative 2, so I can factor this. X plus 4 and x minus 2. There are my factors, and they equal 0. So set each factor equal to 0. So I have x plus 4 equals 0, and x minus 2 equals 0. So x equals negative 4, and x equals 2. So I have two solutions, and now I need to check to make sure that both of them are in the domain. So I plug in negative 4. When I plug in negative 4 into the first one, so negative 4, I plug in, and negative 4 plus 3, well, that's negative 1. Right there, I can stop because I have a negative inside a log, so therefore I know negative 4 is not a solution. Let's plug in 2. I plug in 2. 2 plus 3 is 5, so that works. And then 2 minus 1 is 1. That works. So therefore, it works. So that is my only solution. My extraneous solution is negative 4. Now, here's an exponential equation. Notice that normally when before we looked at equations that had the same base on, we could change it into the same base on both sides of the equal sign, and then we just set the exponents equal to each other. Well, here there's no way I can make 7 with a base 3. Can't do it. But I still need to solve this problem. Well, I have an exponential, and I need to get that x out of the exponent slot. So what I'm going to do, I'm going to ln, and I could actually use any log base, just ln is the easiest and quickest to write. So that's why ln both sides. So when I ln both sides, now I can move that x and move it into the front here, because that power can be moved to the front. So now it's in the front. Now I can solve for x. So I divide both sides by ln of 3. And that is my exact solution. So there'll be times that I'm going to ask for the exact solution. Well, this is the exact solution. You can also put it in the calculator for an approximate solution. And my math lab will ask for both or either. So you just got to find out what my math lab is asking for. This is the exact solution, and here's the approximate solution. So the decimal is the approximate solution, but the exact solution is ln of 7 over ln of 3. That's the exact solution. Now, I want you to try this problem. Well, let's do this one together. We have 5 times 2 to the x equals 3. Well, I need to get the exponential by itself. So let's go ahead and divide both sides by 5. Now I have the exponential by itself. But once again, there's no way I can make 3/5 into a base 2. So I'm going to ln both sides. So now when I ln both sides, I can take that x and I move it to the front. Now I can solve for x by dividing by ln of 2. Now, once again, this is your exact solution right here. That's my exact solution. This is my approximate solution. Okay? So you have your exact solution and your approximate solution. Now I want you to try this one on your own. I'll work it out and I'll pause for you to work it. So there's no way to make 14 with a base 3. So I'm going to ln both sides. So I have ln of 3 to the x equals ln of 14. now that I've done that, I can that x can now move to the front. So that's going to be x ln of 3 equals ln of 14. Now I can divide both sides by ln of 3. And that gives me x equals ln of 14 over ln of 3. That's my exact solution. And I can put it in the calculator to find the approximate solution. So you can put that in the calculator to find the approximate solution. I don't have my calculator handy. So you can do that. So here, this problem is a little bit different. In a way, it's similar. We still have bases we cannot make 5 into base 2 or 2 into base 5. I can't do it. So I still have the exponents have variables in them. I need to get those down. So the only way to do that is by ln'ing both sides. So I'm going to ln both sides. Now that gives me the opportunity to bring down those powers. Now, notice something. When I brought down the powers, I put them inside parentheses. That's very important. The whole power is being multiplied, so you've got to put it inside parentheses. So that's something to really take note of. So notice these parentheses here. That is very important. If you don't put those parentheses there, it's going to screw you up. And that's where I get a lot of people mess up on these problems. So make sure to put those parentheses. Just kind of think of them as little parentheses here and here, and then you just got to use those parentheses when you bring them down. Now, to get rid of the parentheses, I got to do distributive property. So when I distribute, I get x ln of 2 minus ln of 2 equals 2x ln of 5 plus 3 ln of 5. So now it still looks like a mess, and I understand. What we're going to do is going to move everything with an x in it on one side of the equation and everything else to the other. So I'm going to move this with an x. I'm going to bring it over to the left-hand side of the equation. I'm going to move the negative 2 ln of 2 over to this side of the equation. So I'm going to subtract 2x ln of 5 and add ln of 2 to both sides. And that gives me this. So now I have x on one side of the equation. I have it over on the left-hand side of the equation. I can factor out that x. I factored out that x. Now I have x kind of by itself, but it's being multiplied by something. Well, to get rid of multiplication, I have to divide. And there it is. It's ugly, but that is the exact solution. So here's the exact solution. And if you put it in the calculator, make sure when you put it in the calculator, you put the whole numerator in parentheses, and you put the whole denominator in parentheses. It's very important, or you're going to get it wrong, or it's going to screw up in the calculator. So put the whole numerator, put it in parentheses, put the whole denominator inside parentheses. And remember, sometimes calculators will automatically, when you hit ln, give you a parentheses. You got to close it around the 5 and close it around the 2. So remember that. The calculator may do that. Now try this on your own. I want you to try it. Even if you mess up, I want you to find out where you mess up, but try this one on your own. Okay, let's work it. So I'm going to ln both sides. Now I can bring the powers down. Remember, you put it in parentheses. So x plus 1 ln of 2 equals 1 minus 2x in parentheses ln of 5. Now I do distributive property. So I have x ln of 2 plus, well, 1 times ln of 2 is just ln of 2. And then ln of 5 times 1 is ln of 5 minus 2x ln of 5. So now I need to get all the x's on one side of the equation and everything else on the other side of the equation. So I'm going to move the 2x ln of 5. I'm going to add 2x ln of 5 to both sides of the equation. And I'm going to subtract ln of 2 to both sides of the equation to do that. So I have x ln of 2 plus 2x ln of 5 equals ln of 5 minus ln of 2. Now I have all my x's on the left-hand side of the equation. I'm going to factor out an x. So now I can get x by itself by dividing everything by ln of 2 plus 2 ln of 5. So I divide everything by ln of 2 plus 2 ln of 5. So that gives me x equals ln of 5 minus ln of 2 over ln of 2 plus 2 ln of 5. So there is my exact solution. If you want to put it in the calculator, just make sure that you do all the parentheses. Parentheses on the top and parentheses on the bottom. Okay? Now, try this one on your own. Okay, let's solve this. So I need to condense. So I have subtraction, so I'm going to divide. So I have log of 2x, because it's positive, it goes on top, divided by x minus 3, because I'm subtracting that one, equals 1. Now I need to change it into an exponential, but there's no base. So what do we remember about a log with no base? What we assume the base is going to be? It's a common log, so it's going to be log base 10. So now I can make this into an exponential. So I have 10. So 10 to the first power is just 10 equals 2x divided by x minus 3. Now I need to solve for x. So I'm going to multiply both sides by x minus 3 to get that out from the denominator. So that gives me 10 times x minus 3 equals 2x, or 10x minus 30 equals 2x. Got to solve for x. So I'm going to subtract 10 from both sides, or 10x from both sides. So I have negative 30 equals negative 8x. Divide everything by negative 8, and I get 30 over 8 equals x, which reduces to 15/4.